Good morning, students. Welcome to today's class. My name is David O. Lemo. I'm the mathematics instructor for White Knight Academy at the senior level. We have been considering trigonometry and we are still on it. But today we are going to be considering special angles. The topic of today's class is titled Special Angles, and at the end of today's lesson you will be able to determine the trigonometric ratios of angle 30 degrees, angle 60 degrees, and angle 45 degrees. And also you will be able to solve composite triangles with special angles, and also you should be able to find the sides of given triangles using special angles. Okay, so we're going to be starting with angle 45 degrees. So we want to determine the trig ratios tan, sine, and cosine of 45 degrees. And in order to do that, we're going to be considering a right angle triangle ABC. So this right angle triangle ABC, such that we assume that the adjacent sides of this right angle triangle is 1 unit each, and the hypotenuse, we are going to determine the value of the hypotenuse first. And if the adjacent sides, side AB and side BC, if they are 1 unit each, that means they are equal. So we say that AB is equal to BC, which is equal to 1 unit. The unit could be centimeters or meters, depending. And so in order to determine the value of the hypotenuse, we use Pythagoras theorem. So we state that the sum of the square of the adjacent sides of the right angle triangle is equal to the square of the hypotenuse. And mathematically speaking, we have AB squared, side AB squared plus BC squared will be equal to AC squared. So the value of AB is 1, so we substitute 1 here. The value of BC is also 1, so we have 1 squared plus 1 squared will be equal to AC squared. And so 1 squared will be 1, because 1 times 1 is 1, and so you have 1 plus 1 is equal to AC squared. So 1 plus 1 is will give you 2. So that means that the value of AC squared is 2. But don't forget, we are looking for the value of AC, the side AC, which is the hypotenuse. And the reason why we have a square here is because of our formula, the Pythagoras theorem. And so, in order to determine the value of AC, we take the square root of both sides. So the square roots will cancel the square on my right hand side, and then so the square root of 2 will be root 2, square root of 2, and we leave it that way. Now, we also have that triangle ABC, since the two adjacent sides are equal in value, that means that it is going to be an isosceles triangle. So triangle ABC is both a right angle triangle and an isosceles triangle. Why? Because the reason why it's an isosceles triangle is because the two adjacent sides are equal. An isosceles triangle is a triangle that has two sides equal. And so we have triangle ABC as an isosceles triangle, and due to that, the adjacent sides of this triangle are equal. So therefore, the base angles of an isosceles triangle are also equal. Yes, and so angle C and angle A are going to be the base angles, so to say. They are going to be the base angles of this isosceles triangle. And so, since AB is equal to BC, length AB is equal to length BC, therefore angle A will be equal to angle C. Angle A will be equal to angle C, which will be equal to 45 degrees. And the reason why angle A is equal to angle C is because they are the base angles of this isosceles triangle ABC. Alright? And in order to prove that, we already have angle C to be 45 degrees. So now angle A plus angle C plus angle 90 degrees is equal to 180 degrees. Why? Because the sum of angles in a triangle is 180 degrees. And therefore, our 90, we collect like terms, 90 will come to this side. So you have 180 degrees minus 90 degrees, and that will give you 90 degrees. That's why we have angle A plus angle C is equal to 90 degrees. Yeah. Okay, so therefore, since this is an isosceles triangle, angle A and angle C is going to be equal automatically. So, and that will be equal to 45 degrees. Angle A will be equal to angle C, which is equal to 45 degrees. Okay. Alright. Now, let's go a step further. We have been able to establish that in this right angle triangle, number one, the two adjacent sides are taken as 1 unit each, and then we were able to determine the hypotenuse to be root 2, square root of 2. Why? Because it's an isosceles triangle and it's also a right angle triangle. And then angle C and angle A, they are equal in value, and then both of them are equal to 45 degrees. So let's go a step further. Then using SOHCAHTOA in our triangle, sine 45 degrees, sine, we know according to the formula SOHCAHTOA, the sine of the angle will be equal to the opposite side over the hypotenuse. And likewise, the cosine of the angle in question will be equal to the adjacent side of the right angle triangle over the hypotenuse. Likewise, the tangent of the angle in question will be the opposite side over the adjacent side. And so the angle in question here is 45 degrees. Okay, let's go back to our diagram so that we can understand better. So that means that we'll say that sine 45 degrees, this is 45 degrees, will be equal to opposites. This is the opposite side, opposite over the hypotenuse. This is our hypotenuse. So sine 45 is equal to 1 over root 2. Sine 45 will be equal to 1 over root 2. And so that's what we have. And also, cos 45, we also use cos 45. So cos 45 here is adjacent. Cosine is adjacent to my hypotenuse. So cos 45 degrees will be equal to the adjacent side, which is equal to 1 unit, over the hypotenuse, which is equal to square root of 2. So that means that cos 45 also will be equal to 1 over root 2. And you should be able to observe that the value of sine 45 degrees is equal to the value of sine cos 45 degrees. They are equal, they have equal value. And okay, we go a step further. Tan 45 degrees will be equal to 1 over 1. That's opposite over adjacent. Opposite over adjacent. So tan 45 degrees is equal to opposite. These are opposites, these are adjacent. So that's 1 all over 1. And therefore, tan 45 is equal to 1 over 1. So 1 over 1, or 1 divided by 1, is equal to 1. And so from this, you don't need a calculator again or a 4-figure table. With this, you should be able to know sine 45 degrees is equal to 1 over root 2. Take note of that. Cos 45 degrees is equal to 1 over root 2 also. Then tan 45 degrees is equal to 1. And that is why this angle is a special angle. It's a special angle. Alright, let's solve an example. In this example, we're told to solve the triangle JKL completely. Yes, solving it means finding what we're not given. And of course, in this case, the sides. So we're going to be finding that our angle 45 degrees is on the upper part of the triangle. So that means that the opposite side is going to be side KL. The adjacent side is going to be side JK, which is given as 5 centimeters. And then the hypotenuse is JL, which is unknown. We don't know. They didn't give us the value. So we are going to look for side JL, which is the hypotenuse, and side KL, which is the opposite in this case. Alright, so let's go a step further. Now the solution, here lies the solution. Since we are looking for KL, we can look for KL first, side KL, which is the opposite. So we're going to have opposite over what? The only value we have is 5 centimeters. So we have 5 centimeters, we have angle 45 degrees, and then so this is the only unknown. This is one of the unknowns, sorry. And so that means that tan 45 is equal to KL, which is the opposite, over JK, which is the adjacent. So you can see it here, tan 45 degrees is equal to KL over 5 centimeters, which is JK. And that implies that 5 tan 45 degrees, we cross multiply. Because 5 goes to multiply tan 45, therefore we have 5 tan 45 degrees is equal to KL. And this implies that 5 times 1, because the value of tan 45 degrees is equal to 1, according to what we derived. And 5 times 1 is 5. Therefore, the value of length KL or side KL will be 5 centimeters. We have found the value of side KL. Then, in order to determine the value of the hypotenuse is JL, and then originally we were given JK, which is our adjacent in this case, is adjacent to angle 45 degrees. So JK, which is the adjacent side, is 5 centimeters. We're going to be using adjacent over hypotenuse, and that is cosine. So CAH, C-A-H, cosine is adjacent over hypotenuse. So cos 45 degrees, which is adjacent over hypotenuse, equal to 5. 5 is the adjacent in this case. So 5 is the adjacent over hypotenuse. Hypotenuse is length JL, which we don't know yet. Now, according to our derivation, we derived from the diagram that cos 45 degrees is 1 all over root 2. 1 all over root 2, square root of 2. Therefore, cos 45 is written as 1 over root 2 is equal to 5 over JL. And therefore, we're going to cross multiply. So JL multiplies 1. JL times 1 is JL. Then root 2 multiplies 5. That will be 5 times 2, which is 5 root 2. Now, when you see something like this, 5 root 2, generally speaking, is called a surd. It's called surd. That's another topic. Surds, S-U-R-D. So numbers like this are referred to as surds, and there's a way we treat them. So JL is equal to 5 root 2. And therefore, GL will be equal to 5 times the square root of 2 is approximately 1.414. 1.414. When you press your calculator for the square root of 2, it will give you 1.414 to 3 decimal places. And then when you multiply 5 by 1.414, you get 7.07 or 7.070. And we approximate it to 1 decimal place. That's 7.1. You can see that there are 2 decimal places, 0 and 7. And so 7 is above 5, is bigger than 5. So we round this 0 up to 1. So we round it up to 1. So that's why we have 7.1 centimeters. That means the value of the hypotenuse is 7.1 centimeters. And don't forget, the hypotenuse is the longest side of a triangle. You can see that this 7.1 centimeters is longer. 7.1 is bigger than 5. So 7.1, which is the hypotenuse, is bigger in value than the adjacent side, which are equal. 5 centimeters, 5 centimeters. Alright, so that is an example based on angle 45 degrees. Now we want to consider 2 other special angles, angle 60 degrees and angle 30 degrees. They are also special angles. So we want to determine the trig ratios, tan, sine, and cosine of these 2 angles. And in order to do that, we're going to be making use of an equilateral triangle. So we're going to be having an equilateral triangle ABC. It's equilateral. Sorry for this. Equilateral. Okay. Equilateral triangle. So this equilateral triangle, that means all the sides are equal. An equilateral triangle is a triangle with all the sides equal. So that means that side AB is equal to side BC is equal to side AC. The length of AB is equal to the length of BC and is equal to the length of AC. Okay, and this time around we are going to be making use of, we are going to assume that the sides of all the sides are 2 units each. So this is 2 units, and BC is also assumed to be 2 units. Okay, but the next thing we're going to do is that we draw a perpendicular line from point A. Point A is the vertex of the triangle. We draw a perpendicular line straight down to side BC. So this perpendicular line is going to be at right angles, angle 90. This is an angle 90 degrees here on both sides. And this vertical line that is drawn from point A, which is vertex, down to meet side BC is going to meet side BC at point D. So we label that point D. So we have ABCD, point ABCD. All right. So this is a vertical line. So this AD is referred to as the height of the triangle. Is the height of the triangle. Now, since we already have side AB to be 2 units, AC to be 2 units, and BC to be 2 units, this perpendicular line that is drawn from point A down to point D along the side BC is bisecting side BC. Bisecting means dividing it into 2 equal parts. So we say that AD is the height, and it is bisecting, is the height of the triangle, bisecting BC, side BC at point D. So therefore, BD, I beg your pardon, length BD or line segment BD will be equal in value to line segment DC. So that means that if BC is 2 units and BC has been bisected, has been divided into 2 equal parts, therefore that means that BD will be equal to 1 unit and DC will be equal to 1 unit. 1 plus 1 is 2. 1 plus 1 is 2. So that will give us our 2 units back. Now in triangle ABD, triangle ABD is a right angle triangle. In triangle ABD, we are using Pythagoras theorem. Pythagoras theorem works actually for right angle triangles. So right angle triangle ABD, using Pythagoras theorem, that means the sum, the addition of the squares of the adjacent sides of this right angle triangle ABD will be equal in value to the square of the hypotenuse. And in this case, the adjacent sides of triangle ABD are side BD. Side BD is an adjacent side which is 1 unit in length. Then side AD is also another adjacent side, but we don't know it yet. We want to determine it. And so, but we know the value of the hypotenuse, which is AB, and it is equal to 2 units in length. So AD squared plus DB squared is equal to AB squared according to Pythagoras theorem or Pythagoras rule. So AD, we don't know it yet, but we know the value of DB or BD to be 1 unit. So we slot in 1 unit, that means we have AD squared plus 1 squared is equal to 2 squared. Our AB is 2 units. Therefore, AD squared plus 1 squared is 1, and 2 squared is 4. So AD squared plus 1 is equal to 4. Then you collect like terms or subtract 1 from both sides. So that means that AD squared is equal to 4 minus 1. Bring 1 here, so it was plus 1 here to be minus 1 here. So that means 4 minus 1, and 4 minus 1 is 3. So since we are looking for AD, and we know that AD squared, the square of AD is 3, therefore the value of AD, we are going to take the square root of both sides actually. Take the square root of both sides, or you say AD is equal to square root of 3. And that means that the value of length AD, which is the height of the triangle here, is going to be root 3 units. Okay. Therefore, we go ahead to determine the trig ratios of sine 60, cos 60, tan 60, and also cos 30, sine 30 degrees, and tan 30 degrees. So sine 60, sine is opposite over hypotenuse as usual. So in this triangle, let's check out. So we are using triangle ABD. Triangle ABD. We are using triangle ABD. So sine 60, sine is opposite over hypotenuse. So sine 60 is opposite, and our opposite here is length AD, which is root 3 units. The value is root 3, square root of 3. So sine 60 is equal to opposite root 3 over hypotenuse 2, root 3 over 2. Therefore, sine 60 is equal to root 3 over 2. We can see that. Then cos 60 also, cos 60 will be adjacent. Cos is adjacent over hypotenuse. So cos 60 is equal to adjacent. This is our adjacent. This is our hypotenuse. Then, so that means that will be 1 over 2. Cos 60 degrees is 1 over 2. And then we are left with tan 60 degrees. So from our triangle tan 60, tan is opposite over adjacent. tan 60 is opposite, root 3, opposite over adjacent. So that means that tan 60 degrees is going to be root 3 over 1. And root 3 over 1 is root 3. Then let's go for cos 30 degrees, sin 30 degrees and tan 30 degrees. So we're going back to our triangle ABD. So in triangle ABD here, our 30 degrees is up there. So therefore, using angle 30 degrees as our reference angle this time around in triangle ABD, the opposite will be 1 unit, the adjacent will be root 3 units, and then the hypotenuse remains the same, 2. So therefore, cos 30, cos is adjacent over hypotenuse. So cos 30 is adjacent, this adjacent over hypotenuse. That means that cos 30 degrees is root 3 over 2. Then sin 30, sin is opposite over what? Opposite over hypotenuse. So sin 30 degrees is equal to opposite, so this will be our opposite this time around over hypotenuse, 1 over 2. And lastly, tan 30 degrees is adjacent, opposite over adjacent. I beg your pardon. Tan 30 degrees, tan is opposite over adjacent, so tan 30 is opposite 1 over adjacent, root 3. That's 1 over root 3. So that's that. You can see that cos 30 degrees is root 3 over 2, sin 30 degrees is 1 over 2, and tan 30 degrees is 1 over root 3. Now I would like to call your attention to something based on what we learned in the last class, complementary angles. You can see that the value of sin 60 degrees is root 3 over 2, and the value of cos 30 degrees is also equal to root 3 over 2. That means that sin 60 degrees is equal to cos 30 degrees. Then you can see that cos 60 degrees is equal to half the value, and then sin 30 degrees, the value of sin 30 degrees is equal to half. If you press your calculator, you get 0.5. Yes, if you also do this sin 60, you get 0.8660. Either you press your calculator or you check the four figure table. And if you divide root 3 is actually 1.732. So you have 1.732 approximately over 2, and that will give 0.866 approximately. So now we can see that, so that means that 60 degrees and 30 degrees are complementary angles. So to show you that the idea of complementary angles is also reflecting in this class. But tan 60 is not equal to tan 30. No, they are not. It's not applicable there. Okay, so let's go a step further. There's an example. So we have an example here. In this diagram, in this triangle, right angle triangle QRS, we are asked to find the value of x and the value of z. So our reference angle is angle 30 degrees. That means that using angle 30 degrees as a reference angle, the opposite will be QS, side QS, which is 3 centimeters in value. The adjacent will be X, which is will be RS, whose value is taken as X unit. And then the hypotenuse is RQ or QR, whose value is Z units. And therefore, the solution lies, here lies the solution. We are using SOHCAHTOA. SOHCAHTOA, that's the formula. Sine is opposite, S for sine, O for opposite, H for hypotenuse. C for cosine, A for adjacent, H for hypotenuse. And T for tangent, O for opposite, A for hypotenuse. Alright, so in this case we are looking for the adjacent side and the hypotenuse. So we're going to be starting with sine. Sine 30 degrees will be opposite over hypotenuse. So the only unknown here is the hypotenuse, which is Z in this formula. So sine 30 degrees is equal to 3, which is the opposite, over hypotenuse. You label it QR first. And then this implies that now the value of sine 30 degrees is half according to our derivation. Sine 30 degrees is equal to half, and then half will be equal to 3 over QR. And then we're going to be here, you can see this sign. This one means cross multiply. We are cross multiplying. Therefore, QR goes up to multiply 1, and then 2 goes up to multiply 3. So therefore, QR is equal to 3 times 2, which is equal to 6. And that means that the value of QR, which is Z, which is taken as Z, is equal to 6 centimeters. Alright, then, in order to find the value of RS, which is the adjacent sides, we're going to be making use of opposite over adjacent, and that is tangent. Tangent is opposite over adjacent. Therefore, we're going to be saying tan 30 degrees is equal to opposite. Our opposite is 3 centimeters, and our adjacent is x unit, or rs, is length rs. That's the adjacent. And this implies the value of tan 30 degrees is 1 over root 3. Therefore, 1 over root 3 will be equal to 3 over x. 3 over x, we replace the rs with x. And then we cross multiply it. You can see the sign, cross multiplication. So then that means that x goes up to multiply 1 and root 3 goes up to multiply 3. You can see that. And this implies that x is equal to 3 root 3. 3 root 3. Oh, okay. I left it that way, but you can go a step further. The value of root 3 is 1.732. And when you multiply 3 by 1.732, that should give you like 5.196. Yes. So you can approximate. So these are examples of special angles. So angle 45 degrees, 30 degrees, and 60 degrees, they are special angles, because of their value. Their value is easily can easily be determined. You can easily remember their values and work with them that way. Though there are some other special angles like 0 degrees, 90 degrees, and maybe 180 degrees, but that one is left for some other time. And here we have 3 exercises. We have exercise 1. You should be able to handle that. Number 1, okay, 60 degrees. Okay, and then you have a 45 degrees here. So, and then for the third question, here, we are having a combination of two triangles. It's a composite triangle. So we have triangle right angle triangle ABC, and right angle triangle ADC. So those are 2 right angle triangles that are merged together. So they both share the same height. So in this case, in triangle ABC, our reference angle is 45 degrees. Therefore, you are going to have AC as the opposite. You're going to have BC as the adjacent. And you're going to have AB as the hypotenuse. So we're given side BC as 4 meters. We're given the adjacent side of triangle ABC. Then in triangle ADC, we have our reference angle as angle 30 degrees. And so AC is still going to remain, length AC is still going to remain the opposite. It's opposite angle 30 degrees. And then DC or CD will be the adjacent to triangle in triangle ADC, in right angle triangle ADC. And then the hypotenuse will be AD. Okay, so with that, you should be able to work it out and give the correct answer. We have come to the end of today's class on special angles. I hope you enjoyed the little time we had together. I want to believe that you understand it. Okay, so next week is another time, and do your assignment and submit them. Once again, my name remains David Olimo. Have a wonderful week.